All right. So let's look at what we have here. Yes, I'm really sweaty today. This is not good. All right. So I'm just waiting to start. Um, I need to confirm if my stream is actually running pretty well. So I'll just go ahead and open this. Okay. So we have a stream. I need to confirm if my stream is actually running pretty well. So I'll just go ahead and open this. Okay. So we have a stream. Okay. I think I'm good to go now. See, I'm not in the mood for a bad network today. Please. All right. Okay. So yesterday I was trying to solve this question, the diffuse the bomb problem, and I had a bit. I think I was running late, and also I actually didn't fully understand the question, right? Well, anyways, I've solved this question. Afterwards, I did research on it, and I understand it now and how I'm supposed to go about it. Okay. Right. So the approach I was going to use yesterday was to increase, duplicate. Hold on, where was it? Anyways, I started this yesterday. Let me just drag this here. Oh no, close this. Yep. So count good. So this wasn't it. Playground. Yeah, I think this was the implementation I had yesterday. So I was going to, I saw someone did a very interesting, someone implemented it in a very interesting way, and I had um some some sort of revelation from that, but it was not really clear as to how I was going to uh implement the third case, right? Because the question says, let me just read it again. You have a bomb to defuse and your time is running out. Your informer will provide you with a circular array code of length n and a key k. To decrypt the code, you must replace every number, right? All the numbers are replaced simultaneously. If k is superior to 0, replace the ith number with the sum of the next k numbers. If k is less than 0, replace the ith number with the sum of the previous k numbers. If k is equal to 0, replace the ith number with the ith number with 0, basically. So if k is equal to 0, replace uh, every item in the code array with 0. If k is less than 0, replace every item in the array um with the sum of every previous number, right? So yeah, same thing for k superior to 0. Now, as code is circular, of the next element code n minus 1, right? n is the length of the code. So code n minus 1 is 0, right? So the last item is actually 0, and the previous element of 0 is code n minus 1, which it's kind of, I mean, I struggled a bit with this, right? Trying to understand how we could make an array circular. And surprisingly, there's a way to make array circular, sorry, without needing to duplicate the array. Because one approach I was thinking about yesterday, even I saw it here, right? Somebody made that implementation somewhere. I don't remember where I saw it, but let me just see. It is one of the Python solutions, and what the person did, yeah. So I think, yeah, this is it. This implementation here, what the person did was to basically duplicate the size of the array, right? Let me just increase this time to 50 minutes. I'm not doing more than 50 minutes today. So they duplicate they duplicate the array, right? And then use every position in the duplicated array as the circular array. So let me show you what's happened. um I'll just, how do I delete this? Okay, so okay, I can do this. I can take this out, right, and take everything here, delete. Okay, so the array is supposed to be um circular, right? We are giving a circular array. Right now it doesn't look like a circular array. You know I tried to explain it in a way yesterday, but I wasn't even understanding it myself. I represented the array with a circle, right, and put every item on the circle, right. But this won't work, right, because if we're to look to the front of this 5, right, I mean, we'll have everything all the way here, right, which is you know what the question is asking us to do. But in terms of code, right, we just have our array, and we know the last item in the array, right, is always only going to be at position length of the array, right, length of code minus 1. So this is where this last item appears in this code array. But the question is asking us to make this last item, right, the first item as well, depending on where we are, right. If I was here, right, 4 will no longer be the last item in the array, right. 4 will be down the first item in the array, the beginning of the array itself. So how do we implement something like this? Well, according to this solution, where is it again? Hold on. Yeah, so according to this solution, the person, increased the size of our array. So we'll end up with something like this. So instead of this array, right, instead of this array like this, we'll end up with an array that looks like this: 5 7 1 4, and then 5 7 1 4, then we'll have 5 7 1 4 again, right. So this will be the new size of our array. But the problem with this is, I mean, there's no problem per se, right, because we want to sum every item or every number in front of the first item in our original array. So our first item in the original array will be this, right, and to sum everything up, everything in front of it, which is going to start from this point all the way to this point, right. this 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 will be easy, right. At this point this will be easy, right. We can sum all the way here because we want the value of k is 3, so we want 3 items at a time. But when we are at this point, where we are 7, where we are at position 7 here, how do we get 3 items? Because now what will happen is we'll have after 7, right? After 7, we'll have 1, 4, and we are supposed to come back to 5 because 5 will be an item in front of 7. So with this duplicated array, that will be possible, right? Because we'll definitely go this way. So we'll know 1 is in front of 7, right? 4 is also in front of 7, and 5 is also in front of 7. So we are good, right? Which is why we need to, duplicate the array. And in case of 1, right? In case of 1, we can go this way. We can start from the 3 numbers in front of it, right? So this is 4, 5, 7, right? So we'll take 4, 5, 7 as well, and we'll calculate the total, the sum of these 3 items here, and replace it with where 4 was in our original code. So this is how this approach works, right? In terms of duplicating the array, right? Because when you duplicate it, basically every item you had at first will appear, a second time in the array, but it will appear after the last item of the original array. So again, this kind of mimics the fact that we have, the first item, right, as the first item, even when we are at this point, right? Even when we are at this position and we want 3 more items, we can just go from 4 all the way to 5 and then 7. But it will be easy with a duplicated array. We will just do, 1 here. We'll start from this place. So we'll go 4, 5, and then 7, right? So, I mean, this approach is good, but I was still a bit skeptical about, as I did not understand, right? I did not understand the part where k has to be less than 0, right? Because if k becomes less than 0, then it means we will take every previous value before the current index, right? So let's say we are at this position, right? This is I. Let me use a different color. This is I, right? This is I is equal to 0 here, which means every previous value, right, of this code will be, I mean, every value that came before 5, right, would be, 4, 1, and 7. If you look into our duplicated array, you'll see 4, 1, and 7, right? 4, 1, and 7 will, be behind these 5 here, right, which is the first item in the array. But when we are at this point, right, when we are at 7, what are the items that are before 7? Again, it will go like this. It will go 4, 1, and then 5, right? And if you look at this part here, this will be so 7 here, right? It'll be 4, 1, 4, 1, and then 5. This was the only part that was confusing to me, right? Because I actually did not understand it. I'm sure at some point I will understand it, but for now, I didn't, want to waste my time trying to really dig in. But there was a hint, right? There was a hint that was given in this case. So as the array is circular, use modulo to find the correct index, right? Sorry. So as the array is circular, use modulo to find the correct index. This was like a revelation to me because I didn't know I could actually use modulo to get an item, I mean the index of an item in the array, even when the index is out of bound, right? So that was really good. And a second hint is that the constraints are low enough for a brute force solution. So I mean that is not really what we need to know, but this first hint here was absolutely helpful, right? And we'll see, hold on, we'll see how to do that now. But before I implement it, I'll show you some things that are really really I mean exciting for me as I was working on this problem, right? So with Modulo, right, you can always get the size of your array, right? You can get the correct index even when you are out of bounds, right? So let me say I have this array here, right? Let me just go let me copy this array here. So this code is equal to this. In fact, I'll just copy everything, right? I just need to show you how this works. So here we have one array. So okay, I'll just comment this out because I don't need it now. So let's say if we're to access the last item in this array, or let's start with the first, right? So we'll do print Christ, print code at 0, right? When we do this and we run this code, right, we'll get 5. 5 is the first element in this, or the first item in our code array, right? So to get the last item, what would we do? We'll do first of all, let's get the length of the array, right? So I'll just say n is equal to the length of the array. I'll say code length of code, right? Like this, length of code. And I'll also print this alongside the first item. So let's just print this and see. Right. So now you can see the length of our array is equal to 4. Now, but we know we start counting from 0, right? We start counting every item from 0 in our array. So getting the 4th item in this array, right, using the length of the array is not going to work. So to get the last item, we have to do getting the nth element. Sorry. So when we do n code at n like this will not work. This will give us an error, right? To say it's out of bounds, because now, sorry, it's out of range. It's out of range. So the index is out of range. So to get the last item in this array, we can just simply do n minus 1, right? So this will give us the last item in the array. Still, this is the length of the array. So this is the last item we have in our array, which is really good. But this time around, we still want to be able to get the first item even after the last index here. In other words, even when we're at n minus 1, right, when we increase n minus 1 by 1, or when we're at n, so if I add 1 to this, right, if I add 1 to n minus 1, I will get 4, right, because this will be equal to 3. So even when I get 4, it should still go back to the first item. It should still go back to 5 here. So how do we do that? Well, for us to do that, we simply need to use the modulo operator. Now this will simply calculate and return the remainder, right? So if you do n, which is 4 modulo 2, the remainder is going to be 0. So 0 is what? 0 is the first item in our code array. So let me just run this again, and now you can see we have 5. And with this, we are done, right? This is like the most important piece to know in order for us to solve this problem. And that's it. That's all, right? So the only thing to do now is to iterate through the array, right? Where we are iterating, so we don't even need an extra array. We don't need to duplicate it. The modulo will simply help us, go back forwards, right? Go back to the front, even when we are out of bound. If I say, so instead of doing modulo 2, right, we have to do modulo n, right? Because this is the length of our array. So let's just do it this way, right? N modulo n. Let's say we do n plus 1, right? So n plus 1, which means we are moving, even further from where we are supposed to stop. So this will give us the second item in the array. Sorry, this is out of range. So, oh, I know what happened. So instead of doing so we are not going to use the length, right? We are not going to use the length of the array. We are going to use two indexes, right? And those two indexes are going to be based on the size of the k, right? The value of k and the current position where we are, right? So let's say at I, where I is equal to 0, 5 is going to be equal to 0, right? Um I is going to equal to 0, which is 5. So we want to add every value in front of 5. This is going to be simple, but in the case where we are at this point, right, or let's say even 7, we want to get 3 items. It means we have to take this, that, and then the next item in the array, right, or the item in front. So what do we do in this case? So in this case, I is going to be equal to here. So I is going to be equal to 1, right? So when I is equal to 1, we have to add 1 to it, right? So it will start from this point. So that will be 2, right? The value there will be 2, and we'll do this again. We'll add to this one 2, right? So 2 here is this item in the array, and 3 will be at this point, and then 4. So every time we do, right, we'll get a round value, right? We'll come all the way here, and when we're at this point, even when we're at 4, right, so I is going to be equal to 3. So we'll do 3 plus 1, which is 4. And if we find the modulos of this, right, it will give us this item here. And then when we increase j by 1, right, which is our second pointer, it will be 5. So 5 modulo 4, right? The length of this array is 4. If I put 5 here, it will give us the first item in the array, which is 7. So we don't have to go out of bound, right? So and then where we are at when we are at 6 F, right, we will get 1 as our return value. And every time we just do these calculations and add the value at the particular index that we want to add it at. So yeah, so I'll go ahead and implement this. Oh, come on, my network is gone again. I don't know what's happening. This is not good at all. Can you stay stable? All right, so I mean, let's just implement this straight away, right? I can just do what's the title of this? Decrypt, right? So decrypt is supposedly a sliding window problem, right? So I'm just going to decrypt. I think I should be adding the code, right? This is what I'm supposed to be doing. LEETCODE 1652. So let's come to sliding window. I'll just put this here, Python file. I'll say leet 1652, right? 16552, and set this to be equal to decrypt. Because me too, I forget sometimes which question this really is. But anyways, we are here now. Let's just copy. So I'm just going to reset this. I don't need that. I'll just copy whatever I have here and paste it here so that I can implement this solution. So I'll import this namespace, and yeah, okay. So decrypt. So first of all, we need to start with our first edge case, obviously. So we know if k, sorry, if k is equal to 0, we know we want to return, sorry, we want to return an array with 0, right? So we'll do 0 how many times we don't even need to do times 0 for I don't even need for in code, right? So this will return 0 for every element, every item in code, right? So that's number 1. And number 2, if k is superior to 0, right? If k is superior to 0, so we want to start iterating through the array. So we want to do for I in range the length of the code, right? For I into the length of the code. Now this is the first part. So in every iteration for I, we need to calculate the k numbers, or the k numbers in front of that particular item, right, at index I, particular item in code, right, in the code array and at index I. So which means, so I'll say I'll have a local total. So I'll say I'll call this local total, right? I'll set this to local total and set this to be equal to 0 for now. And when I'm iterating through the rest of the items, in other words, the items in front of the current item here, right, at I, then I just need to start. So since we are starting in front, right, for j in range, I'll do range. I'll start with I, right? I'll start with 1, sorry. I'll start with 1 because I want to start with 1 item more than whatever we have, right? So I'll do that. And what else? So I will iterate for the exact amount of k items we want. So I'll pass in k here. Now if I pass in k here, this range function will iterate only up to k minus 1. So I want to go I want to include the k item, kth item in the iteration. So I'll do k plus 1 as well, right? So now we need to calculate the total, right? So how do we calculate this total? Well, this is going to be fairly simple. So we are going to start with we are going to include every item. So I'll just say so sum, local total, okay, local total plus equal, so plus equal the item at, so I'll call this code, and then what I need to do here is to just say code so the first, so this is going to be I plus j modulo. It's supposed to be I need to find the length of the array, so I'll just calculate. I'll say I can't use n, I'll just use n is equal to the length of the code, right? So code modulo n, right? I'll do it this way. Oh, come on. Modulo n. So every result we get from this place, right, we are going to add it to our local total. Now at the end of the day, we want a final array, right? So I'll call this I'll not create the array until we are at this point. So I'll say results, right? Or I'll say decrypted. Decrypted is going to be equal to an empty array for now. So here, once I'm done iterating, right, I'll just say decrypted at I, right, should be equal to our local total, right? And this is all we need to do, right, for the first iteration. I mean, for the first case where k is superior to equal to 0, right? So what's happening here? I'm set to local total. Even before I run this, right, let's just print the local total every time. So print local total here. So I will do this. I'll say solution is equal to solution. Let's instantiate that, and I'll print solution dot decrypt, and I want to decrypt so code equal to 57. Let me just put this here, just copy everything. I mean, I can still put it here, right? So uncomment that, and I'll just do code here and then set this to k, right? So this will be our values. Let's just print this. Now you can see we have 12, 10, and so on, right? So let's just add this to our decrypted. So I'll call this, I'll print the decrypted instead, right? At the end of everything, I'll print the decrypted. So if this is down, once this loop is done running, just print decrypted. So print decrypted, right? So when we print decrypted, you will see hold on, decrypted. Oh, okay, so decrypted has no items at this point, so I need to make it have a certain amount of items. So I can just do I can still do something like this, right? Instead of, okay, so let me just do it this way. So since we need I'll just cut this here, post it here, and instead I'll return decrypted for now, because I already know it will have item filled with 0. So let's run this again. Now you can see our decrypted code works fine. Now it's left with the second case where the items, I mean k, is less than 0. So we'll basically follow the same principles, right? Because the reason why we are adding j to I is to get the items in front of the correct ith element or ith number in the code array. So for us to get the previous one, we'll simply do what? We'll simply subtract, right? We'll subtract the value of j from the ith element or the ith index. So I'll just say if, or I don't even need an if, so I'll just say else, right? Else we just need to do for I in, again, range the length of, sorry, the length of the, okay, I don't even need length here. I'll just put n here because I've already calculated it here, right? This is what we have. So length, or no more length, I'll just use n straight away. So these are a bit modular. So the next thing to do is to just calculate the local again. So our local is going to be, sorry, local total. I mean, this local total is different from what we have up there, right? it's scoped to this part only. So you know, we are not modifying any value outside of this. So you just say for j, again it's still the same thing, but this time around, instead of doing plus, we'll do minus. So for j in, again we start the same thing in range in range 1, right? We start from 1, and now this time around, because the value of k is going to be less than 0, right? We need to get the absolute value of k, right? So we'll just do abs, right, k plus 1, right? So that's all, and we begin to calculate. So local total is simply going to be equal to plus equal to code at I minus j, right? Again, the modulus operation, right? And we then set the decrypted at the end of the day. So decrypted at I is going to be equal to the local total. So at the end of the day, we'll still return the local total here. So let me just shift this quickly. Okay, this needs some spacing, right? Okay, so here's solution 2 for the third case, right, where k is less than 0. And this actually works, right? You know what, let me print out what this is each time we run this. So I'll print the before and after, right? So I'll call this before when we just do code at I plus j. I'll call this before. Let me put it in front. This is going to be, yeah, let's just put it like this. Oh, okay. I'll put it here like this. Oh, I was supposed to turn this to a string formatting. So here, just say it like this. So I'll call this before. I'll say before is this, and just copy this, right? And then I'll call this an after, right? So after, and this actually works. And in case of any circular array problems, right, this is one of the best ways to go back to the front of the array even when you are out of range, right? So after, right, when I run this, right, you'll see that this code will not work. It will print out some error at some point. So I'll just copy this again. It will print out an error at some point, right? At the point where, so I'll print I as well. So I print I here. So at the point where I is equal to 7, we'll have an error. So it's already in the second iteration, right, we'll have an error because we don't have the values at this point. After 4, right, this calculation will go out of bound. You know what, instead of printing yeah, let me print it this way first, right? You can see we have an error here which is pointing at this point. So instead of printing it this way, I'll just print I plus j, right? I'll just do the calculation instead so that we'll see the value at that point. So you can see I, it's at 0, right? At 0, which is the first item, we went all the way from 1, 2, and 3, right? So 1, 2, 3 is simply going to be 7, 1, and 4, right? In the second iteration, we have 1, right? So we are at this point here, the 1th or the ith item in the code array. So we are at this position, and you can see in the inner loop, right, or in the inner for loop, the second for loop is going to start from 2, right? 2 is 1 here, and 3 is the last item in the array. But we don't have 4, right? We don't have 4. If we had used the modulo operator here, you will see that a conversion will happen, right? This will simply transform this back to 0, and it will come to the front of the code array here, and will simply point at, you know, at 5 at this point, right? And same thing will happen when um when the calculation, when I plus j is equal to 5, right? We also want to do a want to transform it to a readable value, right? So we'll find the modulus, or the remainder, when we divide these two values by one another, right? So we'll divide 5 by 4, the remainder will be 1. And what is 1 in our original array? In our original array, 1 is equal to 7, right? The item at index 1 is 7. So let's quickly transform this to a modulus operation. So I'll just do this and paste it here. So instead of us getting 5 and 6, right, we will no longer get 5 and 6. Instead, we will get, at this point, we'll have like a 2 and then 3. So let's just run this again, right? So you can see we went all the way from 1 to 3, right? From 2, 3 to 0, right? We went back to 0. And then from 3, you can see now from 3, 0 to 1, and then 0, 1, back to 2 again, which is, you know, the reason why we're able to sum up every value in the array. So the same thing will work for you know, k here, this second condition here. So I'm just going to copy this and test it in LeetCode, right? So there is no need for me to continue printing. Let me just remove all these prints here, right? So I'll say, is there any print again? So it's just 1. Okay, so I'll just copy this, right? And so let's run this code and see. So this should pass all the test cases, right? Oh, there's one wrong answer. What's that? K is equal to 3. Expected. We're returning. Oh, am I not returning? Oh, okay. I'm not returning anything here. Sorry, that's bad. I can return. Let me just return the decrypted at this point, right? So return decrypted, yeah. Okay, this has passed all 3 test cases, and hopefully it passes the main one, right? So yeah, you can see this is an effective solution as well, right? And it works just fine. So the next question we have here is, so I'll just quickly add this to GitHub, right? At the end of the day, I want to return, so return decrypted. Okay, so I'll commit this as my first change. So I'll say, hold on, git add, sorry, oh, git commit -m. I want to call this it's LeetCode 1654, right? What's it? Oh, 1652. 165252, right? Oh, I'm supposed to use leet dash 1652 16552, right, and call this decrypt. Yeah. Okay, so that's it for now. Let's solve the next question, and that'll be it for tonight. So I'm just going to go. So the next question is on linked list, right? We want to print out the middle of a linked list. Now, my approach to this question is quite, I would not say it's the best, but it was just straight out of my head when, because I solved, or due to the way I solved some linked list question, right? Because I know in order for me to insert an item at a specific position in a linked list, I will need to traverse from the head all the way to that point, right? And the same thing happens when you want to access an item at a particular position. You still need to iterate through the nodes in the linked list, right, from the head towards the point where you want to stop. So let me just copy this. I'll take this image here and I'll put this here. So, oh, I didn't even read the question because I had read it before, right? And what this question says uh is 876 middle of the linked list. So given the head of uh a singly linked list, right, return the middle node if the linked list, right, um sorry, given the head of a singly linked list, return the middle node of the linked list. If there are two middle, return the second middle node, right? And if what is okay, so if there are two middle, right, meaning we have an even number of items in the linked list. So let's say in this case now we have six, right? So we have with six, let me just take this here. With six item in our linked list, right, we know the middle will be this, right? The middle will be from here. Oh, come on, what am I doing? The middle will be from here all the way to this point, right? That's the middle of our linked list. And we can't just return both nodes, right? So we want to return the node after the first middle, right? So the first pair. So this is going to be the node of this, or the next node after this 3 is 4. So we return 4, right? Our results will look something like this. 4 will have a next value of 5, and then 5 will have a next value of 6. 6 will point at none, right? So that's it. Otherwise, we just return the middle, right? The middle, in the case of um, an uneven amount of nodes in the linked list, right? In that case, come on. In that case, we simply get the middle, right? The middle, to get the middle is not going to be difficult. We simply need to just get uh the middle. So when we divide 5 by 2, right, we'll get a middle, but the middle is going to be an the result is 5 divided by 2 will give us 2.5, which is a decimal number, right? So we want we'll simply take the 2, right? We'll simply forget about the decimal, and we know when we start counting items in our linked list, the second so let's say we start counting from 0, right? I mean, I like counting from from 1 in terms of linked list, but in this case, let's just try counting from 0, right? So when I start counting from 0, right, I'll have 1. You know what? No, I don't need to count from 0. I can start counting. I can start counting from. I'm still thinking, if I start counting from 1, right, I'll have 2 at this point, right? So which means I'll return the next value of this node here, right? I'll return the next value of this node, which is going to be equal to this 3 here. So if I start counting from 1 here, if I divided this by what? So if I divide this by 2, so this is going to 6 by 2 is going to be equal to 3. So we'll have 1, 2, 3. So I'll return the next value of this node as well. I think that will work. Yes. Yeah. So first of all, my approach is going to, I'm very sure it's not going to be very efficient, but it is quite reasonable to first of all know how many items you have in your linked list, right? To know the size of your linked list, because it's going to be an input and we don't know, how big or large this input is, right? So we need to get the size of the input first, right, of the input linked list, and then we can then just use that. We can find the middle by just dividing that size by 2 and rounding up the value, and then we'll have a second loop again, which is where things get very interesting. So we'll have a second loop that will iterate from the head, right, the original head, all the way to the value we got, right, the middle we calculated. So when we get the length of this linked list here, let me just use this example. When we get the length of this linked list, this is going to be 6. So if we divide 6 by 2, we'll get 3, right? So we'll then iterate again from 1, 2, and then 3, right? This is where we stop. So we get the next value of this 3. The next value is going to be this node here where 4 is, right? So the next value is that. And the same thing will apply to this case. So we'll do 5 divided by 2, right? So we'll use the double division sign so that it rounds up the result to the nearest value, right? Nearest smallest value. So this is supposed to be 2.5, but since we did this, right, since we did this here, we'll have 2. So we'll iterate 1 and then 2, and then we'll return the next value of this node here. The next value of this node here is going to be equal to this 3 here, and we'll return 3. 3 will point at 4 and then 5. So yeah, that is my brute force solution. So again, I came across another implementation that was even much better than this, right? And that is, first of all, they were going to start counting. They'll have 2 pointers, right? A slow pointer and a fast pointer. So the slow pointer is basically going to start from this point, and the fast pointer is going to be 2 pointers ahead. So they are all going to start, but at the same position, right? I'll call this, let me use this, fast and slow, right? So, oh no, let me do this. We'll have our slow pointer, and how do I do this? I'll say fast like this, our fast pointer. So I want to be able to drag it. So our fast pointer is going to be 2 steps ahead of our slow pointer, right? So for every 2 steps our fast pointer makes, our slow pointer will make 1, right? So our fast pointer will still move to this point, and our slow pointer will move 1 step. And by the time our fast pointer is at a position where the node does not have a next value, or the node has a next value of none, right, our slow pointer would have been at in the middle of the linked list, right? So which is this point here. So we'll simply return 3, right? I'm not sure, I'm running out of time to implement this right now. Otherwise I'll just implement it, and you know what, let's just do it. Even though I'm late, I'll just implement this instead. I'll implement the first solution, and then maybe the second solution you can get it on GitHub. So this is 876 middle of linked list. So I'll say 876, right? So linked list is a linked list question. So I'll say, come on. Lit dash 876 dash middle. I'll say mid. Yeah, middle of linked list, right? Linked list LL for linked list. So, this is going to be fun because I'm not going to use LEETCODE's inputs because this is I don't know. So I'll implement a linked list, right? I'll implement a linked list. I'll implement how to print items from the linked list, and then I'll also implement the middle function, right? So brace up and let's get started. So first of all, we need to create a node class, right? So we'll need a node class, and our node class is simply going to be instantiated with a value, right? So let's say we need this, and we need to pass our node class a value. I'll just shift this a little. So we'll need a value for our node, and yeah, so basically we'll need a data. Our node is made up of data, right? Data, which is simply the value we pass in, and we'll have, come on, what's wrong with my hand? We'll have a next value set to none, right? Our next value is going to be set to none. Now let's implement our linked list class. So class, right? Class linked, linked list, right? I'll call this a linked list. And then what we need to do is to first of all create an instantiation method or a constructor, right? Sorry, this is going to be init self. Now we don't need to pass it any value. Now our linked list is going to have a head, right? So self dot head is equal to none at first, because there's no item in the linked list for now. Now let's see how we can add items to our linked list. So we'll define a add node function, right? Add node method, in other words, in terms of classes, right? And we'll pass it a value, right? The value we want to add. And for this, we'll instantiate the node class, right? So this is going to be our node, and I'll set this to node and pass it the value. So that's it. Now if we have a head that is empty, or in other words, our head is pointing to none, right? Is none, right? So we'll simply set the head here. So we'll say self dot head, right, is going to be equal to the new node we just created, right? And then we just return here so that nothing else runs. Now in the case where we already have a head, right, so we need to simply get that head. I'll call this current current node, right? As usual, this is what self dot head, right? This is going to be the head of my node, and I'll just say while so this while loop, or this iteration, is just going to help us traverse the head all the way to the last node in the array, or the node that has, come on, oh my god, my stream is going to end. Jesus, no way, please. Oh, come on, what's happening? This is painful to be using a very supposedly good network. I'm struggling with this. I hope this doesn't end my stream. See, when it stops like that, people will just leave this stream. It's not good. It's not a good experience, and I don't even blame anybody for it. So anyways, let's continue. So we set the current node. While the current node is not none, right? We want to set the current node to the next node. Current node should be equal to the current node dot next, right? And then at the end of the day, we'll just say current node, right? Until we get to that point, current node should be equal to the new node. All right, with this, we've implemented our linked list. We implemented how to add the function to the linked list, right? So what we need to do next is to be able to print out the linked list. So I'm just going to, what's happening? Oh, sorry, current node dot next. Yes, the current node dot next, right, is going to be equal to the new node. All right. Is this? Wait. I've done it already, right? So I'm just going to I'm just going to take this, which is printing the nodes in the linked list, right? I'll just take this. I'll just take this and I'll just put it here. Now we have current node on next, so this will print our linked list for us, right? And let's just implement one of this. I'll just copy add item, linked list. Yeah, so I'll just copy this and print the linked list. So let me just paste this here. It's add node and not add item. So I'm just going to replace this add item with add. Oh, come on. Add node, right? So I replace all of this with add node and just close that. I will also take this, right? Print linked list. Yeah. So let's run this. And okay, so current node dot next has attribute to none. What's going on? Hold on. Wait. What is it? Current node dot next has no next attribute. So if the current node okay, so I think this was the mistake I was making. So if the current node has a next value, or alright, set the current node to the next. Okay, so this should work now. Yeah, so we have 5, 2, 3, 5, right? Let's add one more, or even let's add the values we have in so we have 1, 2, 3, 4, 5, right? So we'll try and get the middle node here. So I'll replace this with 1, 2, 3, 1, 2, 3, 4, and 5. Okay, so let's print this. I can see, so the middle node will be 3, right? So here's what I need to, I'll define this function separately. This will not be a function of the class itself, right? So I'll say define middle node, and I'll just, so this is going to be middle node, right? Middle node will take a head, right? We'll give it a head, which is the head node of our linked list, right? So what I need to do first of all is to count, right? So I'll say count. I'll call this node and linked. I'll say list size. List size is equal to 0 at first, right? So I'll say current. It's usually like this, right? Current node is going to be equal to the head here, and then we'll just say, okay, for okay, let me use a while loop. While our current node, right? While our current node, so the head will have a next value. Okay, so we'll say while current node, while current node is not none, it's still the same as while current node, right? So while current node, we want to do what? We want to count our list size. So list size is going to be incremented by 1, and we'll simply get the current node to be the next one. So current node should be equal to current node dot next. Okay, so that's it, right? Current node dot next. So what do we need to do next? Let me just return this so that you see the size of our linked list. So return linked list size. Although this is not what we want to return, we want to return the head. So let's say print middle node, and we'll pass it this linked list solution. Oh, that's a very long name. Dot head, right? So when we run this, you'll see our linked list will have a size of how many? 5. Yeah, so the size of our linked list is 5. So now we will first of all get the middle. So this is my approach. I'll get the middle, so I'll say middle is equal to the list size, right, divided by 2, right? And then I'll iterate all the way to this point, right, all the way here, and then I'll return the current node at that point. So I'll say so for I in, I don't even need I, so for in range, so we are starting from 0, right? No, we're going to start from 1. Yeah, we'll count from 1. So 1 all the way to where? To the middle plus 1. Middle plus 1, right? Now, what do we do? So we'll say, do we still use this? Because at this point, the current node would have changed to a different node. I'll just say new current, which this is why this solution is not. I'll say new current is going to be equal to the head again, right? We always have to start from the head, and we'll say new current. I will not call it new current. I'll call it okay, I mean, this will be the possible middle, right? So we are looking for the middle of this node here. Anyways, so we just say new current. I'll say middle node, right? Middle node, and I'll set this to middle node dot next. Oh, I've done 1 hour already. Dot next, and so this will set the next value each time, right? We don't want to come here. I mean, we want to start from 1, so 1 to all the way. So if this was 2, we'll start, so we'll get the next value from 1 and 2, 1 and 2. So it's to do twice, and we'll return the, so let's say our middle would then be return, oh, so not the, we'll say middle node. So we'll set the middle node each time, so just return middle node dot next. Yeah, so let's see what this will give us. Our middle node should be what here? Should be 3, right? Are we returning middle node at next? Hold on, we need to print this dodo. How do we do it now? You know what, middle node, I'll just say dot data. Let's see where this stopped first. So this is 3, so we are not supposed to go all the way here. Sorry, my bad. So it's supposed to be 2, and then we get the next value of 2, right? So middle data, instead of data, I'll just say next. Yeah, so this will give us the next node, which is from 3 down. If I, let me just, I made a function, I created a function. So this outside print linked list, yes. So let's use this to actually observe what's going on the inside. So here I'll just print, instead of printing the, okay, I mean, I can call this function, right? Instead of passing it, I'll store it somewhere. I'll say middle node, middle, I'll just say middle. Let me just call it a middle. Middle is equal to this, and I'll say, I'll call the print ll print linked list and pass it the middle, right? So this will show us from 3 all the way to 5 here. This is cool, very nice. So that is it. That's my solution for now, but I am very how do I say it? Let's see. If we had, more than, I'll just copy this. If we had more than 5 elements where the items are now even, right? So the middle should be 4. Yeah, it started from 4. Okay. Why is the none not here? Oh, okay, we are printing data, and here we are printing what? We're also printing data, but we set current afterwards. Hey, current node, a head. Oh, current node dot. Okay, so let me run this in LEETCODE and see what we'll have. So I'll just copy all of this, right? And so our input is a head, so we are good with that. So I'm just going to shift this inside. Let's run this and see. Fingers crossed. Yeah, the test cases have been passed, which is good. So let's submit this and see. I'm not sure about the submission part, but hopefully, yeah, I think so. I also thought so. So output is 0. Your expected 1. If we have 1 head, oh, what was that stated in the wait? How many? Oh, it's just 1 test case that we missed. So we're almost there. I mean, I'll say return. Okay, so if the current node, sorry, if the current node, right, dot next, I mean, if not current node dot next, so I'll just say if not current node dot next, then return the head again. Return the head. Just return this head. Yeah. So return the head. Submit it again and see what goes on. Yeah. Okay. So that's the solution for this particular one, and yeah, I think we're good to go. So I will submit this as well. So git add. Oh, come on. Scheiße. So we want git bash. So git add git commit dash m. We want lead dash 876 dash, middle of linked list like this. So git push origin main. Yeah, so that's about it for today. You can access all the solution on GitHub from the link in the description, and we shall continue tomorrow. Bye.